You probably expected the Grok to speak here, and honestly, I expected him to speak too. But 2 days ago, I inherited his talk, so bear with me that I don't have any live demos or free accounts to give away. But anyway, it's going to be interesting. So, what I'm going to do is I'm going to talk about what is voice over IP and certain kind of voice over IP, namely ZIP, the Session Initiation Protocol, and how do networks look like, what protocols are used, since I'm basically just focusing on ZIP itself, but there are way more interesting protocols to look at. And eventually, some conclusions, but the main thing would just be ZIP-based attacks. And what is VoIP? VoIP is generally considered really cheap, both for the industry. Like if you're an ISP, you don't have to run both a PSTN network to carry PSTN calls and your IP network. You just do your PSTN calls on your IP-based network, so you save one whole network setup. And from an end-user perspective, it's cheap, since users just won't switch to voice over IP if PSTN is still cheaper than voice over IP. It's in production use today. I'm with a large ISP, and we are peering with a bunch of ISPs, and there's a sheer amount of users and lots of minutes being pushed per day. And in the US, there are the first companies who are actually replacing standard PSTN setups with voice over IP. And one of the interesting features is free calls. You can do free calls, like free local calls in the US or probably within your own city. In the US, you can usually do free calls on a larger scale. And with voice over IP, your ISP usually allows you to do free calls within this very same community, like all users within one domain. But voice over IP also converges with the PSTN. So all the network equipment that was safe from users, like you couldn't really ping your PSTN gateway or do any kinds of attacks to your PSTN gateway, but blue boxing, are now being exposed to the IP network. So step by step, some of the PSTN equipment will be replaced by IP-based systems. And it's growing rapidly, and it's immature. Like, there used to be one ZIP RFC, and it has been replaced, and there have been lots of additions, and pretty much on a weekly basis. There are either new RFCs or just drafts with features to replace or to build all the features that are present in the PSTN network. So they're going to be available in the ZIP network, although some of them are pretty much useless. But to convince a user to actually switch from the PSTN network to the voice over IP system, you have to be able to provide all the features he likes to have, that he depends on. And another thing is voice over IP, even in transit setups or when talking to peering partners, it's used without TLS. So there's no encryption of signaling, no kind of real authentication between peering partners. And you can see signaling, so who's calling whom. You can, at some points, even see real data, like voice streams. So I'm going to the kind of quickly to this, since I've got a lot of slides on the ZIP stuff itself. Talking of infrastructure, so what does a VoIP system consist of? You're going to have your voice over IP-based phone. It could look like a hardware device. There are some manufacturers that offer like the Cisco phone that you're going to see in all those nifty movies, or you might have in your office. Or you can have one of the AVM or routers or Siemens-based boxes that you get with your DSL access, and you just plug in an old DEC telephone into it, the phone you already have at home. So switching from the PSTN network to voice over IP isn't that much of a hassle. You just switch the plug and everything should work. And then there's a bunch of companies, namely Snom, which is a very good one from my point of view, they just built a real phone that looks like a standard ISDN or DECT phone, has most of the features, and just voice over IP underneath it. It has a web server, IP address, everything. And on the other side, you can have software phones, like software like Skype you've got on your laptop when you're traveling. And one of the popular ones is Xlite. There are companies branding that phone and selling it or giving it away to customers for free. And in the Unix world, there's Kphone, which is pretty good. And there's some other ones picking up pretty fast. To make everything work, you're going to have some sort of zip software in your network. This is usually a so-called registrar. That's the point where all the phones sign on to, just, okay, I'm here. And if somebody tries to reach you, he would contact that particular server, and that particular server would know if you're online and which IP address you currently have. Then there are so-called route or proxy servers, which could divert traffic, like for peering purposes or some sort of PSTN interaction. And another feature which doesn't have anything to do with zip calls themselves is called presence, like ICQ. So you can see which of your friends is currently online. So you can just, see, okay, he's not online. It doesn't make any sense to call him using VoIP, so I just call him on his PSTN account instead. Okay, PSTN integration, there's 2 parts to that. Just talking of voice, you've got to make calls from the VoIP network into the PSTN network, and you have to be able to pick up calls from the PSTN network if you've got a phone number in your voice network to get the call from the PSTN into your zip cloud. And then you've got auxiliary services, like you have to be able to do billing. If you've got paying customers, you want to get their money, and you have to do billing. It's kind of tricky, but you can do it, and there are different approaches on how to do billing on voice over IP networks. Then you've got web interfaces, like change your user settings, see your call lists, who called you when you're not available. Then you've got media proxies, instance servers, just to help with net problems and all those sorts of issues. And there's a lot more to that, but this is just the basic setup. So how does it look like? On the left side, you've got a bunch of zip clients. Could be standard soft phones or software phones. Could be an AVM box. Could be some sort of Cisco phone or whatnot. You've got a zip proxy. And if you're just doing voice over IP to voice over IP calls on using zip protocol, you just, one zip client tries to reach somebody, and he's just sending a message to the zip proxy, and that proxy would know where the callee is and just forwards the zip message to the callee. But nonetheless, the real media, like the voice data, is just flowing between the 2 zip proxies. So you don't have to have that much of bandwidth on your zip proxy to get it done. And then you could have zip peerings, like voice over IP-based peerings, like 2 different companies are peering with each other and allowing their customers to call each other for free. So you're going to have a second zip proxy in that route. So if you're calling somebody at a different zip ISP, the call would be directed to your own zip proxy, and that zip proxy would know, okay, that phone number you're trying to reach is connected at a different zip proxy. So he just forwards on the message to the other zip proxy, and the other zip proxy would know where to push the packet to actually place the call. And in addition to that, you have the PSTN gateways, like zip to PSTN, PSTN to zip. Could be the same box, could be a cluster of boxes if you're talking about bandwidth. Doesn't really matter. So different to the PSTN network, you've got a separation of signaling and media. As I said, signaling is always flowing, and all consecutive messages in the call flow are flowing from one client through the proxy to another client. There's just a few mutual exclusives where you don't have to push all the data through the proxy. And for signaling, you have basically the zip protocol, which seems to be the standard right of now, and it replaced AS323, which used to be a standard and still in use, and there's some gateways running which are translating zip messages to the older protocols and vice versa. And then you've got MGCP, Media Gateway Control Protocol. It's a nice protocol which has a lot of security issues just to control your media gateways. So you have a dedicated box speaking zip on one side and MGCP on another side to kind of hide your infrastructure towards your zip world. It's a nice approach, but has a lot of issues. And Megaco is another protocol, pretty much like MGCP, but MGCP seems to be the winner in that race. And then you've got Skype, which is proprietary, but still a signaling protocol. And there's hardly any interaction between Skype and zip. Some people try to do Skype with zip or otherwise, but we're not supporting Skype. And I can't see any widespread support of Skype in any commercial zip networks. It's just another company, and they are making money, and you want to make the money anyway. So there's no reason for you to peer with Skype. And media is another thing. Media is usually RTP, like real media stuff, real-time protocol, and you've got different codecs in there. You can do audio, you can do video. There's even a draft to do text over IP. It's called text over IP, so it just allows you to push data, random data between two boxes using zip signaling. It sounds funny, but it actually makes sense, since with zip and all the net helping stuff and media proxies, you can traverse a lot of net boxes and firewalls. You won't be able to get through without having stun and all those protocols in first place. So having zip and all the aiding protocols, you can do direct connections or indirect connections between two boxes that won't be able to speak to each other without having zip and stun all those protocols in first place. So that's interesting. And okay, since I'm gonna focus on zip, not MGCP in this talk, just to get an overview on how the whole thing looks like if you're using MGCP. This is just zip. So if you've got a zip client and doing a PSTN call, you're going to have your zip client talking to your zip proxy, and your zip proxy is forwarding your packets on to your PSTN gateway. Your PSTN gateway could be a Cisco access server, could be an asterisk, could be some sort of IP speaking and zip-enabled router that speaks some sort of PSTN protocol on the backside. And in this scenario, your zip server would have to know all the access servers that are capable of doing PSTN calls, like the load levels, availability. Like if some gateway goes down, your zip proxy has to know, and you probably have to reload your configuration. And some zip proxies don't support reloading configuration on the fly. So you have a downtime on zip proxy just because one gateway failed. So you want to preempt that and might go with MGCP. So in that scenario, you've got an intermediate box called Media Gateway Controller, which takes all the zip proxy, all the zip traffic directed towards the PSTN and controls so-called media gateways. The very same Cisco access servers. I'm not sure about if you can actually use an asterisk box and control it using MGCP. Could be some sort of gateway. And the media gateway controller just hides your whole infrastructure for the zip proxy. So it's easier to administer, and you've got a lot of advantages like load balancing and all the stuff that your zip proxy can't just take care of, since you can't do load balancing stuff in zip on its own. So this really is interesting, but on the downside, having MGCP in the middle is hard, since you have to translate all PSTN features into MGCP messages and then into zip messages and vice versa, just to get like caller ID correct or some sort of PSTN features like hold or call pickup. It's hard to do. And another interesting thing is one of the sections of the MGCP RFC says, okay, we know that MGCP is insecure. Like, just read that sentence. They know it's insecure, and there's pretty much just three commands. It's create connection, it's modify connection, and delete connection. And the moment you're able to send MGCP messages to a gateway, you're controlling the gateway. You can divert calls, you can create new calls for free, and at that point, you're behind all billing issues. So if you're directly calling the gateway, nobody would know. There would be no billing ticket written, no nothing. So it's interesting to deal with that, and the Grok had a few slides on that, but I'm focusing on zip, so I'm leaving this out for this talk. So if you're interested in that, just get to me later on, and we could talk about that. So the main talk is focusing on zip. Zip has been specified in an old RFC and then been superseded by RFC 3261, and it's still very much the same protocol. It looks like HTTP. It's plain text. All the status codes are well known from HTTP, like 200 OK, 404 not found, 403 forbidden, authentication required, unauthorized. There's a bunch of well-known one, and there's a few additions, especially for zip. And it looks much like HTTP 1.1 environment variables that you can set, like for cookies or server names and all that stuff. And you've got pretty much key value pairs. Like it's the from address, to address, contact fields. And much like in HTTP, you could have payload. You just say, okay, content length, that amount of bytes, and you've got that amount of bytes on arbitrary data. That could be mine encoded, could be just media information, all sorts of stuff. But in contrast to HTTP, zip is usually being carried using UDP, since if you're placing a call, you don't want to wait for a TCP handshake to finish, then just send a short message, like 500 bytes, and then wait for the other packet in the other direction to come back. You just send a datagram, and if that doesn't, if an answer doesn't come back in a few milliseconds, like 500 milliseconds is the standard time on the RFC, you just retransmit the same packet. So using UDP, which makes spoofing kind of interesting and easy, because you don't have to have the TCP handshake. Nonetheless, zip over TCP is generally supported. It's working. Although some clients just don't speak TCP, zip over TCP. But in some scenarios, TCP might help, since you don't have to care about retransmissions. You just send a packet off, and your kernel operating system underneath will just take care of the packet and make sure it arrives at the other side. So it's easy on that point. And then you've got TLS, it's transport layer security for TCP, which allows you to encrypt your signaling data, which gets interesting. But on the other side, all zip components have to be able to read your data to actually forward the call. So you have to decrypt it on every box. It might take some CPU. You might run into licensing issues if you're running Cisco gateways and whatnot. Another interesting thing is DTLS. I just came across this a few weeks ago. It's TLS for datagrams. So it's UDP-based TLS. So you have all the benefits you have with UDP, but it's still encrypted. But yeah, probably 99.9% of the setups are just using plain UDP. So the downside of zip. The state engine is pretty complex. There's a lot of states, and you can run into race conditions sooner than you know. And it's always changing due to additions. Like I said, certain companies are trying to get all the PSTN features into the zip world. So like Deutsche Telekom is trying to do all the features they have in their PSTN network. It's called communication completion on busy subscriber. Like you're trying to reach somebody, and he's currently talking, and you can press something called, the German word is Rückruf, it's like call back. So the gateway in the PSTN network would know when the person you're trying to reach finishes call, and establish a call to that person, and both phones would be ringing, and you can just make the call. But if you're trying to do the same thing in zip, it's really different. And you don't have any real state engine to know if somebody in the PSTN finished his call. And even if somebody finished his call in the zip world, you won't know if it was a video call, an audio call, or just text transmission or whatnot. So it's hard to do, and companies are paying others to get additions into zip, and they're publishing drafts, and they're implementing drafts, not RFCs, and it's hard to follow. Like from an implementation point of view, you have to do a complete implementation. Like usually you would do it the easiest way, like no white spaces, everything is case insensitive, but nonetheless, if the RFC says, okay, the expire header should be written with a capital E, you're usually writing it with a capital E. But some clients are writing with the lowercase e, and some zip stacks don't recognize an expire header, although it's conforming to the RFC with the lowercase character in there. So one of the worst stacks we've seen sent everything in lowercase, and it wasn't really bad, but on the other side we had another stack who just didn't understand lowercase header names. So from other headers it passed, there was just 2 lines remaining from like out of 20. So there was no way to make a call between those clients. And it's we're fighting on this all the time, and there's pretty much no way for us to do it, but encourage vendors to write stacks conforming to the RFCs and accept all different ways of writing. Then there's different ways of doing things, like route headers. You can do multiple headers underneath, or you can make a list and append to lists. And this is really bad, since for a zip message to find its way back to the sender, you just revert the list. But if you've got a mixed thing of a list of headers and a list that actually contains a list of headers, it really gets troublesome. So sometimes packets just don't arrive at the sender, and you won't be able to make your call. So what's available in the open source world? We've got lots of different stacks. Some stacks are just good enough for a simple client to do calls or just good enough for testing. One of the better ones is libozip. It's really good. You can write clients, or you can just do simple debug applications, like use libpcap to capture all your traffic, feed it into libozip, and actually make libozip parse your zip messages and find bugs or just record things. Exozip is another library. Reciprocate is a well-known library by a company or federation called Zip Foundry. It used to be the first real zip stack, and they are trying to implement all the drafts. It's kind of the reference implementation. And then there's libdissipate. I never played with that one. And client-wise, there's Kphone, Linphone, SFL phone, phone game. There's a bunch of clients. Although I'm using GNOME, I still use Kphone since it's just working. Then you've got a lot of test tools. There's really lots of test tools available just to exploit things or test things, register to a zip server, send arbitrary messages, and zipzec is kind of stateless, but still does a job if you just have to send a zip message. Zip with a double P is a good tool. It's kind of transaction stateful. It's not really stateful, but it's still good, and you can define your own XML-based configuration file and would just do the whole dialog based on your configuration. That's really helpful. And then there's something called the Protos Test Suite. It's one of the first attempts to actually exploit zip stacks and find problems in the implementation. And ngrep supports pretty much all protocols. It's really easy to do, and ngrep is good to just debug zip. You can just make it print zip messages on your screen, so it really helps. Ethereal is nice in generating call flows, doing statistics on voice data, all that sort of stuff, but it's you have to have an X running to get that done, so ngrep would be the usual tool to do administration with. Talking of zip servers, you've got the Zip Express router, which is like, the company behind that, Iptel, says I think they've got an 80% market share, and they're probably true about that. Asterix is, used to be some sort of PBX, connecting to PSTN, they're having their own protocols, and it's a good tool, but if you're just talking about zip, it just doesn't scale as good as there does right now. So if you're just looking for a zip server, not PSTN gateway, not a media proxy something, just go with there for now. And then there's zipd, PartyZip, Vocal has a bunch of libraries, applications, server software. There's everything out there. I've got on one of the last slides, I've got a link to a website that lists all the software and has all the links to the websites. So talking about attacks, so now for the funny part. There are probably buffer overflows in all devices. I expect that there have been buffer overflows in almost everything, and from what we've seen, there are usually buffer overflows in most even the better ones, like zip proxies, Cisco gateways, clients, anything. It just starts with like, you're converting all numbers that you might have in memory to plain text, and on the other side, you have to pass that particular number and put it back into memory. And you're just writing a number that's like larger than 2 to the power of 32. And if you're trying to push that into a 32-bit integer variable, you're going to have some sort of overflow, which, regarding to the zip RFC, might result in negative expire times. Like you're registering a zip client to a zip server, but the expire time says, okay, my entry expired like 700 years ago. So you can have a lot of fun with that. And then you've got race conditions. ZipStack is very complex, and in order to have a really working dialogue, before you can send the second packet, you usually have to make sure that the first packet arrived at the caller and the first acknowledgement from the caller got back to the sender, so you know the whole path. Otherwise, you might run into issues. Like, you've probably seen it if you're trying to cancel a call, you punch in a number, it's a typo, so you just canceled the call, but it might still ring at some random phone you don't know. So that's some sort of issue. And another thing is, signaling is being pushed from your client to a zip proxy, probably onto another bunch of zip proxies, and then to the callee. But if the callee picks up, he sends a message back, okay, I picked up. But at the very same point, he's starting to send media he might actually be sending media before he picked up your call. Like if you're calling somebody on a German cell phone, you're hearing the ringtone from the PSTN network, or some companies are allowing you to play some custom ringtone, like the latest charts entry, whatnot. So that's so-called premature media. And even if you're working regarding the RFC, you're connecting to a call, and the zip message that you're getting connected is sending back to the caller. The media might be at the caller before the first acknowledgement arrives, since media is being sent directly from client to client, but signaling has to traverse a lot of zip proxies on the way. So there might be issues with that. The most obvious ones is getting ICMP unreachable messages, since the UDP port is not open yet for the RTP data. But on the other hand, you might be able to just push RTP data into a client, and the client just plays RTP data, arbitrary audio you want the client to play, without having to actually do something. So that's kind of bad. And yeah, signaling. That's a so-called read and write packet, which allows you to change the codec while placing a call. Like you're figuring out, okay, the connection is not as fast as it could be. We're getting a lot of delay or something. You're just changing to a better codec that has lower bandwidth consumption, lower delay, whatnot. And that allows you to change the codec. But on the other side, it still allows you to redirect media, since you can change the IP address the ITP traffic is directed to, or just support. And another thing is alert info header. It's interesting. You can change the ringtone. Like you can add an alert info header field to your outgoing zip and write, and say, okay, please use this ringtone in the phone. And although you've muted your phone, some clients still play the ringtone. And one of the interesting things is you can append an HTTP URL with a WAV file that's going to be played on the customer phone. So if you want to spam voice over IP customers, it's called SPIT, you just have to put a web server up, put a WAV file on it, and just try to make calls with the alert info header. It might work. Media RTP. It's not really zip signaling, but there's lots of stuff that can be done with RTP. You can inject media. Like clients are usually expecting media to come in once you're connected. But before you're connected, some gateways play a ringtone, and that ringtone is going to be played on the client. It could be like a just cost announcement, like this call is going to be charged you with like 10 cents per second. So that's called premature media. And if premature media is not used, you can play your own, or you can try to replace the media stream that's being called with something else. Like you can obviously do that later on, but if there's no premature media, you don't have to get rid of that in first place. So it's easier to do split in premature media. Or you can do spoof receiver reports. RTP has something called, it's a control protocol, RTCP, and allows you to send, if you're sending RTP media to a client, the receiver report is from the receiver, obviously, and contains information about the quality, like delay, jitter, if there's any packet loss in something. And honestly, since we're dealing with so many net issues, most of the clients are not sending those packets at all. So what's going to happen if you just send RTCP packets saying, okay, the voice quality is so bad, you just have to change the codec. And at some point, the caller might say, okay, we've got 90% packet loss, huge delay, we just tear down the call. Just it doesn't make any sense. So you might be able to tear down calls just by injecting one RTCP packet saying the voice quality is really bad. There's lots of tools to do that, and also there's lots of tools just to record data. Etherreel is capable of doing, of reconstructing WAV files from RTP streams, or you can just divert traffic, so you can easily sniff traffic. That's another interesting thing with RTP. But yeah, now back to the VIP side. Billing evasion. At some point, it doesn't make sense to try to get free phone calls, since ISPs know how to do authentication. They actually have a look at what's happening on the network. But nonetheless, you can try to exploit the system and make a phone call and let somebody else pay for it, or just try to shorten the call. So this usually has to exploit ISP-related features. What ISPs are doing in communication within their zip network is appending some sort of prefixes or private headers in their zip messages, so they can identify a particular client or zip packet on another gateway. So if I want to know if some packet is coming in from a zip peering partner, at my first kind of firewall host, I would just check the packet. It came in from a zip peering partner. But so I can later on another host see, okay, it came from a peering partner, and perhaps not do authentication. But some ISPs are probably not checking if somebody else just faked that header and just appended a header saying, okay, I'm coming from a peering partner, and I don't need to do authentication. So there are probably ways to append your own headers, and the Grok had another interesting thing. They can just set your caller ID just by using a private header that's not being used in any RFC. But you're still seeing the header since you're getting the zip messages back from that ISP, and they didn't care about deleting the header when it left the network. And you can still try to get free calls. It's, from my point of view, it's getting harder, and it's not that easy to get with based on zip. But as I said, you can just get around zip and just use MGCP to get free calls. You can just create a connection and say, okay, just get me the media to my IP address. That's all you have to do. Or you can hijack equipment. Most of the zip hardware actually has web interfaces. Like if you got a Cisco or SNOM phone, it has a web interface to do the configuration, since you don't want to punch in numbers on like hex digits or alphanumeric characters on a dial pad. It just doesn't work. So you have a web interface, and you just log into the web interface. There might be a default password or no password. And what you can usually do is either just get the account information or just initiate a three-party call. Just make the phone, call somebody you want to call, and on the other line, call you, and just connect those two. So the call would be flowing to that particular phone, and that particular guy is paying twice for the call, but it works. So yeah, just there's a lot of Google docs, like these things that you just have to type into Google to get all the IP addresses of Cisco phones, SNOM phones, AVM routers, Siemens routers, all that sort of hardware. So it might be an easy way to not look for bugs in the zip implementation or at an ISP side itself, but just exploit the phones or hijack equipment of any sort. And yeah, zip spoofing. So if you're trying to do free calls, you have to spoof packets. Obviously, you have to spoof a to and from header field and the request URI. The to field will say, okay, who am I going to call? And the from header says, okay, who am I? So that's easy to forge since you know who you want to call. The contact field is just your IP address and your phone number. You have to have that, and you know where you are, so that's easy to spoof. But then you've got a bunch of more tags that you have to fake to actually get that working. There's a random tag which is used to identify one side of the call, and as you can see, it could be kind of hard to guess that one. And the same one still is attached on the to side. So once the dialog has been established, you have two of those tags, which are arbitrary, random size, and in addition to that, to make it even more interesting, you've got a call ID, which should contain a host part, but must not contain, or doesn't have to contain a host part. And regarding the RFC, you have to get all three right to actually match a zip message to an already existing dialog. So you have to have the tag contained in the from header and the to header and the contact and the call ID. But guess what? Not all zip stacks are actually checking for the tags. Those tags are usually just used when doing call forking, probably in third-party calls and some special scenarios. But you usually don't have to check those, and you just leave the tag out or just set something random. It might work. The call ID is still kind of hard to fake, but if you're doing your own dialog, it's just set on call setup, and you just have to use the very same call ID during the whole call. So just get something random and just reuse it. It just works. The call sequence is something to work around kind of race conditions. Like you're placing a call in dialog, and then you're changing media or something, you're sending some other messages, or you're canceling the call, and just so the zip stack gets all the order of the messages right, it increments the call ID. We could start with a random value, but it has to increment. So could be done. And then you've got the record route header. You have to have the record route header at some point if you have to make sure your packet goes the right way. But yeah, usually you can just leave it out and let the first zip proxy take care of routing your zip message. The F tag is so-called feature tag, which in this case doesn't only look like much the same, but is the same. It doesn't have to. It could be different, and you can encode features, like what your zip client supports. So you can set a random thing, and I've never seen a zip call fail since due to a wrong F tag, so just leave it out. As I said, it's hard to guess all values, but luckily, not all devices are checking everything. So if you're placing a call to a zip network, to a PSTN network, and your zip proxy might forward on a packet, but if you're changing the way your packet looks like for consecutive messages, like for the buy or the cancel to tear down your connection, and just change it so your zip proxy does understand it, and your access server does understand it, or probably your access server doesn't understand it at all, or some billing site doesn't understand it, or the government doesn't understand it, it might be lost on the way. So you might be able to do a nifty exploit on that. There's lots of things you can do, like make calls disappear from call logs, like websites and stuff, and you can try to hide from lawful interception, which I'm going to talk about tomorrow. And there's another thing, easy exploit I have on a few slides down, so just wait for that. And yeah, as I said, attacking zip servers on ISPs could be hard, but why not just attack devices themselves? Cisco supports something. If you've got a huge Cisco installation in your network and you have to do a software upgrade, you don't want to run through the office and reboot every single phone. You just at night send a zip message, say, okay, all the phones just reboot, get the latest software, get the new configuration. And the Untitled Zip Express router actually has a command. We just have to add a contact field and make a Cisco phone reboot. It doesn't work on all versions. At some points, you have to have a TFTP server or HTTP server that has some version information saying, okay, the version of the firmware that you're going to load is newer than the version you already have running. So to actually convince the phone that it has to reboot and reload configuration. But it works in most cases. And AVM, a well-known German company, selling lots of DSL routers, has everything much like Mozilla. Mozilla supports everything, but doesn't have a kitchen sink. So on the very same approach, somebody in a forum wrote, okay, the AVM box now supports everything, USB, wireless, everything. But it couldn't fetch my beer. So what AVM did was you just have to punch in --96*6*, and it will display a term called beer holen, like get me some beer, in your ISDN phone display. So there might be some more stuff of that within the firmware, and it's running. The box is running Linux, so you can just use strings to search for more of those. And at some point, it might be interesting to try to send some of those commands from the zip network and probably place a call to an AVM box and then replace your caller ID with beer holen, so nobody would know who's calling. So there's lots of stuff to do with DSL routers. Caller ID, one of the most interesting things Greg mentioned, you're usually identified by your from tag, like the call is from in some so-called display name. It could be a real alphanumeric name, like my name, or it could be your phone number in some random format, and your zip URL, like your phone number you got assigned from your ISP. And you've got something called remote party ID. It's some sort of authenticated ID. Usually, your zip proxy appends a so-called remote party ID, which is your phone number, which is supposed to be displayed if you're doing PSTN calls, or if you've got some sort of zip device that supports remote party ID. It's an old draft, but most clients do support this. You can also do some of the PSTN features already with remote party ID. Like, okay, here's my phone number, but you can append a flag saying, okay, but don't display this on the PSTN side. But nonetheless, it would be carried into the PSTN network so that like law enforcement agencies or like your police department could see your phone number, or the fire department. They have to see who's calling. So it could still be carried into the PSTN network. And one of the later approaches is called peer-asserted identity. It's two RFCs which actually date behind the latest zip RFC. And that really deals with authentication. If you're appending a peer-asserted identity header, you have to make sure, you have to assure the identity of the caller and all those things. But if some ISP doesn't support the latest zip RFC or anything that came after the latest zip RFC, he might not support peer-asserted identity. He might never have heard of that. But you can just append the peer-asserted identity header to your zip messages. And the zip proxy would not filter that out and send it on to the PSTN gateway, and probably make the PSTN gateway display the number you wanted to display in all parts of the signaling. So just play around with that. Or as the group found out, you can set a header called setCallerID and make newphone.net display a random caller ID that you wanted to display without having to set from remote party ID or peer-asserted identity. And one interesting approach that German Spiegel picked up a few weeks ago was just spoof your caller ID from a zip-based network and call some random German phone or some random German cell phone. And since you're coming, you spoof the number you're spoofing would be the phone number you're calling. So on the PSTN network side, you're calling your own cell phone mailbox, your own voice mailbox. So you're being authenticated. Since you're calling your own phone, you want to listen to your own mailbox. You don't want to say anything, but you want to listen to the messages previously recorded. So you can circumvent authentication just by faking your caller ID. So that's an interesting approach, and it works. So as I said, that's an easy attack example just to work around billing. You're the caller, and you're placing a zip call using the zip proxy to the PSTN, and somebody is behind the PSTN. And the first message you're sending is actually making it all the way through the zip server to the access gateway. The call's being set up. You've got voice flowing, everything is fine. And then you send a cancel message or a buy message saying, okay, I want to terminate the call. But you've got a so-called max forward setter. It's much like TTL in IP. And says, okay, that message previously kind of looped somewhere through the network and it expires on the zip proxy. So the zip proxy would still record that the packet arrived and record in the database, in the billing, okay, the call is being terminated. And it might make it to the access server, but then the access server would say, okay, it's expired. Max forwards is reached. I have to throw the packet away, and would keep the call open. So you can just shorten your calls. You would still have to pay for the call, but you can just shorten it. And as of today, there's no way, or no easy way, in the official zip source code to check for minimum value of max forwards on your first zip proxy. So this really makes sense to play around with. And VoIPinfo.org has a bunch of zip-based billing setups. And if you just look up the mailing list and see which kind of companies are posting on the mailing list, you might see which kind of company is using which billing software based on the zip proxy. So if you're sending the max forward setter, which is too low, and you're doing a PSTN call, you might pretty much ruin their billing and get a longer call not for free, but for cheap. So talking about RFCs, there's so many RFCs, but there's one website that tries to keep up with all the incoming RFCs, not the drafts. And this really makes sense to look there, since they've got all the information about anything related to zip, like media traffic, net helping stuff, and everything. And iptel.org's the website of the Zip Express router. They've got a bunch of links. And if you're looking for open bugs, just look at Cisco. Cisco iOS supports zip. They've got a bunch of other zip-enabled equipment. They've got more coming up. And just use your CCO account and just see what's going on there and what's wrong and what kind of funny behavior some people saw in the past. And just see if you can actually use that for your own purposes. And as I said, VoIP.info.org, VoIP-info.org has a bunch of interesting just lists of zip software, so for your operating system, just a zip client, debugging tools, zip stacks, and how to get started. Onzip.org has a bunch of lists just for the zip express router, but I think it's kind of interesting since zip express router is probably the zip server you're going to deal with if you're doing anything zip in Germany or probably in all over the world. So that's usually the first zip server. So knowing that makes it easier to actually see what's really going on. So conclusions. VoIP is emerging and it's being in use, and people are replacing PSTN setups with their own VoIP systems. There are companies running voice over IP and especially zip-based phone systems instead of traditional PSTN systems in companies. And so now is an interesting point where you can actually access PSTN hardware that had been in place for like 20 years, and it's probably some sort of IP enabled. But nobody actually had access to that kind of hardware before, since it was hard to send some sort of signaling messages over your phone line. But now you can actually play around with all the hardware and all the applications like voicemail, billing information, media proxies, everything that's in use, and lawful interception is another thing. And TLS is hardly used, and it should be used even more, but from an ISP point of view, you have to have some hardware to actually do all the encryption and decryption, and it just takes some time to get it done. But if you're setting up your own stuff, yeah, have a look at TLS. And I've been focusing on zip, but MGCP is interesting. You don't have to deal with zip and billing and everything else, and probably not with lawful interception if you're just using MGCP directly. So have a look at that. There's even MGCP-based end-user phones, like hardware phones. They're just speaking MGCP, so you don't have to have zip. Yeah, so that's it. Any questions? Okay, the question was how much SRTP actually helps. SRTP is a good approach, I think, and there's lots of things you can do. You can just change your SDP information in your zip invite to some random codec, and if somebody tries to intercept your call, he might see some random unsupported codec. So that's using something that's not standard RTP might help in finding lawful interception things and other things. But if you're using SRTP, you're doing a PSTN call, your PSTN gateway has to understand SRTP, and it has to do decryption of SRTP and encryption. And if you're running internet issues, your media proxy has to do SRTP. So it's just a huge amount of overhead on the ISP side, and that's probably the reason why ISPs are not pushing SRTP. But it's still a good approach, and from an end-user point of view, it should be used. Okay, thanks for your time then.